Hey there, data enthusiasts! Welcome back to our channel, where we dive deep into the world of data science and machine learning. If you're new here, don't forget to hit that subscribe button and ring the bell so you never miss an update. Today, we're tackling a topic that's crucial for anyone stepping into the realm of machine learning: validation sets versus test sets. So, what's the difference between these two? Why do we need both? Let's break it down. Before we jump in, let me ask you a question. When you build a machine learning model, how do you know if it's performing well? Is it just about the accuracy on the training data? Or is there more to it? Stick around as we explore validation and test sets, and I promise you'll have a clearer picture by the end of this video. Alright, let's get started. First things first, let's define what we mean by validation set and test set. Imagine you're building a model to predict house prices based on features like square footage, location, and the number of bedrooms. You have a dataset consisting of thousands of houses, and you split this data into three main parts: the training set, the validation set, and the test set. 1. Training set. This is the portion of your data that you use to train your model. It's where the model learns the relationships between input features and the output label, in this case, house prices. 2. Validation set. Now, this is where it gets interesting. The validation set is a separate portion of your data that you use during the training process. Its primary purpose is to tune the model's hyperparameters and evaluate its performance while you're still training. For example, you might want to try different values for the learning rate or the number of layers in a neural network. By evaluating the model on the validation set, you can see how changes to these hyperparameters affect performance. This helps ensure that you're not just fitting the model to the training data, but developing a model that generalizes well to new, unseen data. 3. Test set. Finally, we have the test set. This is the portion of your data that you set aside completely until the very end of your model development. Once you've trained your model on the training set and tuned it using the validation set, you evaluate its final performance on the test set. The key here is that the model has never seen this data before, so you get an unbiased estimate of how well your model will perform on new data in the real world. Now, let's look at a more concrete example to illustrate this. Say you have a dataset of 10,000 houses. You might split this data as follows: training set, 70% or 7,000 houses; validation set, 15% or 1,500 houses; test set, 15% or 1,500 houses. During training, you'll use the 7,000 houses to teach your model. You'll periodically check its performance on the 1,500 houses in the validation set to see if it's improving. Once you're happy with the model and have chosen the best hyperparameters, you'll evaluate it on the remaining 1,500 houses in the test set. But here's a critical point: if you start tuning your model based on performance on the test set, you risk overfitting. Overfitting happens when your model learns the noise in the training data rather than the underlying patterns. If you repeatedly check performance on the test set, your model might perform exceptionally well on that specific set of data but poorly on new data. That's why the test set must remain untouched until the very end. To summarize, the validation set is your go-to for tuning the model during training, while the test set provides an unbiased evaluation of the final model performance. Both play crucial roles in ensuring that your model is robust and capable of generalizing to new data. If you found this video helpful, give us a thumbs up and share it with your friends who are diving into the world of machine learning. And don't forget to leave a comment below. What other topics would you like us to cover? Your feedback helps us create better content for you. Thanks for watching, and until next time, happy modeling!